Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, question 4, 2020. The diagram below shows two functions f of x and g of x. The function f of x is given by x cubed plus kx squared plus 15x plus 8, where k is an integer and x is an element of OR. Given that f-3 is equal to minus 12, show that k is equal to minus 9, where f-3 is the derivative of f of x at x equal to minus 3. Okay. So we have our original f of x equal to x cubed plus kx squared plus 15x plus 8. Okay, so if I was to differentiate then so that I could get f dash of x, I would take down the power, reduce the power by 1, take down the power, reduce the power by 1, and then 15. Okay, what they've told us then is f dash of 3 is equal to minus 12. Okay, so let's use this information into this. Okay, so I'm going to come up here now and I'm going to say that if I look at f dash of 3, all right, I'm going to put 3 in that bracket, then that means that all of the x's here gets replaced by 3. So I'm replacing x with 3 here, so I replace all the x's with that same 3. So I'll have 3 times 3 squared plus 2k times 3 plus 15. So that is equal to 3 3s are 9, 9 3s are 27, plus 6k plus 15. And the other piece of information they gave us was that was equal to minus 12. Okay, so 27 and 15, 37, 42 plus 6k is equal to minus 12. Letters to one side, numbers to the other. Minus 42, 52, 54. Divide both sides by 6. 9 6s are 54. Okay, so that is k being shown to be equal to minus 9. So therefore our original f of x would be x cubed minus 9x squared plus 15x plus 8. Okay, all I did there was sub in the minus 9 for the k. Okay, so that was part A. That was nice. B, the function g of x is the line that passes through the two turning points of f of x equal to x cubed minus 9x squared plus 15x plus 8 as shown on the previous slide. Find the equation of g of x. Okay, turning points. So turning points are always found when dy dx, which is f dash of x, it's the same thing, is equal to 0. Okay, so if our f of x is equal to x cubed minus 9x squared plus 15x plus 8, our f dash of x is equal to 3x squared minus 18x plus 15. And we let this equal to 0 to find those turning points. I'm going to divide across by 3 to make the maths easier because I can see it divides in here, here, and here. So I'll have x squared minus 6x plus 5 equals 0. So let's factorize him. Factors of 5 that add together to give me minus 6, minus 1, and minus 5 will do it. If you can't do factorizing, do the minus b formula. I'm getting x is equal to 1, x is equal to 5. So they are the x coordinates of my turning points. You find the turning points. The most important piece of theory I've written down so far is this, okay? So important that you know it. Find the turning points by letting dy dx equal to 0. So they're the x coordinates. I need to find the y coordinates. Okay, so y coordinates then you find by subbing into the original. Okay, so sub x values into the original f of x formula. Okay, because f of x is y. Okay, it's your outputs. So when x is equal to 1, y is equal to, I'm subbing it into the original f of x here now, x cubed, so 1 cubed minus 9 times 1 squared plus 15 times 1 plus 8. So that is equal to 15. Okay, so that is the point then 115. And when x is equal to, what was my other x value? 5, your y coordinate was equal to 5 cubed minus 9 times 5 squared plus 15 times 5 plus 8. And put that one into the calculator. And I'm getting minus 17 for him. Okay, so he is the point then 5 minus 17. So they are my two turning points. Okay, how do you find the nature of turning points? To find the nature of turning points, we use d2y dx squared. Okay, so I'd use d2y dx squared to find out which of these is min and max. Okay, how to formally find out which is min and max. You can always tell which is min and max too, though, by looking at the y values. Okay, so I know he's going to be my minus, because if you think about the y value, it's down here at minus 17. And your x value is up here at 15. But you will formally find them using d2y dx squared. Okay, so I'm not done yet. The function g of x is the line that passes through the two turning points. Find the equation of g of x. Okay, so the equation of a line, y minus y1 equals m times x minus x1. Okay, so I need the slope. So my 2 points, we label x1, y1, x2, y2. And let's find my slope. M is equal to y2 minus y1 over x2 minus x1. Minus 32 over 4, so it's minus 8. Okay, so therefore your equation y minus y1 equals minus 8 times x minus x1. So y minus 15 is equal to minus 8x plus 8. So let's bring them over. Let's write them in the form ax plus by minus 15 minus 8 is equal to 0, or 8x plus y minus 23 is equal to 0. Okay, so that is the equation of g of x. Okay, C, show that the graph of g of x contains the point of inflection f of x. Okay, so point of inflection is a turning point. So remember I said here that you'll find the nature of turning points if you let d2y dx squared, if you find d2y dx squared and test the x values. So a point of inflation, well, I'll do the nature of turning points here. I'll put the theory up here in case anybody needs it. Okay, so d2y dx squared is less than 0 when it's a max turning point. d2y dx squared will be greater than 0 for a minimum point, and d2y dx squared is equal to 0 for a point of inflection. Okay, often called a POI. Okay, so what you do is you test the x values in above. Okay, and you see what answer you get and you compare it to to 0 basically. So we want to show that the graph of g of x contains the point of inflection. So I'd like to find that point of inflection first. So for a point of inflection, I'm going to let d2y dx squared equal to 0. Okay, so dy dx, which is f dash of x, was, see it here, 3x squared minus 18x plus 15. So f double dash of x, which is d2y dx squared, it's the same thing. So differentiate it again. Take down the 2 3s are 6x minus 18, of course, and I'm going to let that equal to 0 to find the point of inflection, and let's solve for x. Okay, so my x coordinate of my point of inflection is 3. Okay, so then at x is equal to 3, let's find my y coordinate. And remember, to find any y coordinate, we sub into the original. So I'm going to sub into x cubed minus 9x squared plus 15x plus 8. So we have 3 cubed minus 9 times 3 squared minus 9x plus 15x, so 15 times 3 plus 8. So that's 27 minus 3 3s are 9, 9 9s 81, plus 45 plus 8, and that is equal to minus 1. Okay, so my point of inflection is occurring at 3 minus 1. And the question said, show that the graph of g of x contains the point of inflection of f of x. Okay, so I want to show that that point is on this graph g of x. Okay, so g of x was equal to, that was the one we just found there, 8x plus y minus 23 is equal to 0. Okay, so let's sub in our point of inflection and see does it satisfy that line. So 8 times 3 minus 1 minus 23, is that equal to 0? So 24 minus 24 is indeed equal to 0. Okay, so the point of inflection 3 minus 1 is on g of x. Okay, so again, this was the theory that you need to know for this one. Okay, so super important.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.